recording. So this is 11.2, question number 2. Write each relative frequency, so I'm going to underline that, as a decimal to 3 decimal places, because that's another key issue here. Telemarketer made 200 phone calls and 35 new customers signed up. So the first thing I want to remember is that instead of relative frequency, I'm going to call that experimental probability, and I'm just going to write EP for experimental probability. And that equals the total number of, see how it's said in the textbook here, of the number of times an outcome occurs divided by the number of times the experiment is conducted. So I could say outcomes, I'm going to just write outcomes, divided by total. That might be the best way to write it down. Outcomes divided by total. Okay, they tend to use tons and tons of words in the textbook. Keep it simple. Now in this case, the outcome, they're asking for what is the relative frequency of getting a customer. That's what they're asking for. So in this case, we're talking about the experimental probability of getting a customer. So you should write that in. I know it's a little bit kind of messy there, but oh, fantastic. Sorry. Whoops. I gotta put the charger on. There we go. Now it shouldn't shut off. So the experimental probability of getting a customer. You can't just write the experimental probability of anything. It has to be of something specific. In this case, we know we got 35 customers. So we do 35 and divided by a total of 200 calls were made. I'm going to zoom up over here and I'm going to turn that into a decimal. So 35, get out my calculator, divided by 200 is 0.17. And I'm going to turn that into a percent by multiplying by 100. Anytime you have a decimal, you multiply it by 100 to get a percent. And that would involve moving our decimal over 2 places. Actually, I believe it's my calculator, which just died, which never dies. Can somebody run and grab me a calculator from the front? Thank you. 35 divided by 200 is actually 17.5, so 0.175. So that would be 17.5%. That's also equal to 17.5%. So the experimental probability of getting a customer is 17.5%. What's the experimental probability then of not getting a customer? Well, I'm going to write that down here. Let's see, over to the right. I'm going to write that over here. So the experimental probability, EP, of not getting a customer. Well, that is the number of outcomes divided by the total. Well, the total stays the same because the total number of calls were 200. In this case, how many people were not customers? Well, we'll do 200 minus 35, and that'll be 165 because 165 people who were called did not end up being customers. So 165 divided by 200 is equal to 0.825. Multiply that by 100. Moving our decimal places 1, 2 over is going to be 82.5%. So the experimental probability of not getting a customer is 82.5%. Notice that these two numbers together, 17.5 plus 82.5, are going to equal to 100%. Because that's 100% of our calls. We had 35 calls, which resulted in our 17.5%, and we had the 165 calls that resulted in nobody signing up. That's 82.5. So the other way, instead of going through all this, is you could have simply done 100% minus 17.5%. That would have given you 82.5. So there's 2 ways to find it in this case. Question B. A quality controller tested 175 light bulbs and found 5 defective. What's the relative frequency, or in this case, we're going to call it experimental probability, of finding a defective light bulb? So the EP of finding, let's say, defective, which means not working, equals the total number of outcomes. So that was 5. There were 5 defective divided by a total of 175. So 5 divided by 175 is equal to 0.0285. If we multiply that by 100, we're going to move the decimal 2 places, 1, 2, and make that 2.85%. So 2.85% of the time, we got a defective light bulb. Well, instead of going through all this for the experimental probability of a good bulb, we could simply do 100% minus 2.85%, which will give us 97.15%. So there's a 7.15% chance of finding there was a 97.15% chance of finding a good bulb in this circumstance here. Okay, so these are things that happened. When we talk about experimental probability, remember, these are things that actually happened. It's not what we guess might happen or expect. They actually did happen. Any questions about these questions? So this is 11.2 question number 5. Use 3 red counters and 3 yellow counters. So I'm going to circle 3 red, 3 yellow. Whatever I'm circling here, you don't have the benefit of circling in your textbook, but what could you do instead of circling? Lakitha?
Write it down.
Yeah, so I do recommend that. Write it down. So the key information on the side, jot it down, 3 red, 3 yellow. You may place some or all of the counters in a bag, so a single bag. Then you pick a counter without looking. How many different ways can you place the counters in the bag so you are more likely to pick a red than a yellow? So let's look at one example here. So if I don't even know what they're doing, I'm going to make a pretend bag, and I can actually get colors here. Make that thicker, and so I can do red, and that's not quite a nice yellow, but let's see if I have red, 1, 2, 3 red, and 1, 2, 3 yellow. Okay, so that's one way that I could put it in. Now the question was, how many different ways can you place the counters in the bag so you're more likely to pick red than yellow? In this case, I'm just as equally likely to pick red as yellow because there are 3 and 3. So this is clearly not going to work. So in order for this to work, I have to at least get rid, whoops, I would need the eraser, get rid of one of my yellows. There we go, I got rid of a yellow, and now I'm in a good situation where I have 3 reds, 2 yellows, I'm more likely to pick a red. Okay, so let's make another bag then. That's one example. So 2 red counters works. Well, I know, whoops, I know if I got 3 is more than the 2, but I could also do 3 and 1. 3 red and 1 yellow. I still have a better chance of picking a red. Okay, so there's another example. Let's try another bag. Well, I could do 3, and then I could do no yellow. There's definitely a better chance of picking a red in this case. Okay, so these are 3 possible examples with 3 red counters in each. But I haven't explored the opportunity of putting just 2 red counters. Well, 2 red counters is great, but if I put 2 or more yellow counters, it's not going to work. So I can only put a maximum of 1 in this case to make the red more likely to happen than the yellow. So that's another example here. Let's make another bag here. I could also do like I did before here with a 3 and 0. I can do 2 and 0, and that's going to work as well. Though better chance of getting a red than a yellow. But that's it. I have no other ways of setting it up with 2 reds. So I'm going to move on to another bag with, in this case, 1 red. Well, with 1 red, if I put 1 yellow in there, I have an equal opportunity of getting both. If I put 2 yellows, clearly better chance of getting yellow, so I have to have it 1 and then 0. So these are my 6 ways that I can set up the counters in the bag so I'm more likely to pick red rather than yellow. And you can see that in each of these cases. You could write it out. You could say 3 red, 2 yellow, 3 red, 1 yellow, 3 red, 2 red, 1 yellow, 2 red, 1 red. In all of these cases, we have more reds than yellows. Any questions about this one? Okay, so the key with this kind of question is it has a lot of parts, and it is not always clear in a problem what they're asking for, even for a teacher. So I often just start drawing pictures or a diagram or anything to get you out of your head and onto paper, because when it's in your head bouncing around, it's not becoming clear. When you put it on paper, you can see it, and then it bounces back to your head and you can become more clear about what you're doing.